Good morning, everyone, and welcome to SeaWeek 2024. My name is Karen from Australian Environmental Education, and today we are going to be looking at where the river meets the sea. So it's important when we're thinking about our marine environments that we don't just think about the endpoint. We don't think about just the coasts, just our coral reefs, just our deep sea oceans or our open oceans. We need to think about how the water is getting to those environments. And in a lot of cases, they're coming from land. And unfortunately, 80% of our marine pollution actually is generated or starts on land and washes into those environments. So we're going to start off looking a little bit about the properties of water and what makes water so important and how it can actually travel and do the things that it does, how it ends up in our waterways. And we're going to do a few experiments on the way. Please feel free to put your questions into the Q&A. If I'm asking you a question, please put those in the chat. And I do have some questions that have already been submitted that we will talk about as we go through the program today. But please put those questions in the chat so we can go through them. So first of all, we had a question originally from Mount Egerton Primary School about how people contribute to keeping our waterways clean for the future. So how can we help fix the problem? And what actions can schools do to help? Five Dock Early Learning Centre was wondering about how clean Parramatta River is. So for those of us in Sydney, Parramatta River is the main river that flows into Sydney Harbour. So it is a really important river for Sydney. And for those of you in other parts of Australia, you can think about the main river that might run through your town or your local area. Sometimes it may only be a creek where it starts with you. Sometimes it might be a really big river, or you may live on the coast or a lake. From Melville High School, students are looking at climate change, and climate change has actually got a really big impact on what's happening now with our marine environments, but also what might be happening in the future. Changes in sea level, changes in our weather patterns. We've seen lots of different big storms, more heat waves. Now, these things are the big climate patterns and weather patterns that we have over long cycles, and they are changing over time. We are finding that we're getting also certain species and animals moving further south than they may have previously. And all of those things do have impacts on our marine environment. So the way climate is changing may be affecting our sea level, the severity of our bushfire seasons and those locations. Then when we have big storms, all of that material washes into our marine environments or our freshwater rivers. We've seen many times that there's been lots of fish kills because of bushfires and the extra material washing into our rivers, creeks, and waterways because there's no vegetation holding it in. And St Mark's Catholic Primary School was wondering, how do humans impact this type of environment? So we're going to explore all of those questions as we go through. The first thing we're going to look at is those properties of water. So we're going to start there. So I'm just going to share my screen to have a look at a few of the slides, and then we will look at our first experiment. So water is an extremely important resource. And if you did any of the sessions yesterday, you discover that 71% of the earth is actually covered in our oceans, but that water is salty, it is seawater. So even though the vast majority of our earth is actually covered in water, we can't use it for everyday drinking for plants and animals and us. So out of all of the water that's on earth, most of it, 97%, is actually salt water in our oceans. That remaining 3% of what we would consider fresh water is actually not accessible, not easy for us to get to. So it's either in glaciers and ice caps, it's under the ground in groundwater. So it's essentially trapped. It's not something that we can get access to. Out of that remaining 1%, we have lakes, soil moisture, water vapor in clouds, and rivers, and only a very small percent of that water that we can get to is actually accessible fresh water for our plants and animals around the world to get access to. So even though we see water everywhere, it still is considered a scarce resource, a rare resource, something that is precious, that we need to look after. So even in times when there is a lot of rain, we do need to be thinking about how we can store that water, use it later. And Australia is one of these amazing countries that we either have it two ways. We either have too much rain or not enough rain. We very rarely have that balance of the right amount of rain in the right places at the right time. And there are many people around the world that access to fresh, clean drinking water is still not easy at all. We get to turn a tap on, and most of us get fresh, clean drinking water straight from our taps, but many places in the world don't have access to that. Now, there are ways, of course, that we can use our ocean water, our seawater, for lots of different things, but we can't use it for drinking. We can't drink salty water. We have to either clean that water like a desalination plant that they built in Sydney after our big droughts earlier last decade. And there are other places around the world that don't have good access to fresh drinking water that they do the same. They use desalination plants. Now, this picture here is called the water cycle. And you might put in the chat for me if any of you recognize any of these parts of the water cycle. So there's some squiggly lines going up. There's some lines going from the clouds, then going back to the ground, and then going to the waterway. So I'm wondering if anyone wants to put in the chat or the Q&A some of those words that we might use to describe the water cycle. So there's some scientific words, but there's also some common words that we use as well. So have a look at the picture, have a look where the arrows are going, and let me know if there's any of those parts of the water cycle that you can name. The sun plays a really big role in impacting our water cycle. And there's some experiments that you can do at school to demonstrate this. Oh, we've got Ramina, evaporation and precipitation. Riley's got evaporation as well. So does Laura. Excellent. So evaporation, oh, Charlie, step one. Water to cloud is water evaporation. Then it turns into clouds and goes into the mountains or hills. And then it warms, then mixes, and it rains and flows into the river, into oceans and lakes. That is a great explanation, Charlie. And thank you everyone for adding your comments there. Oh, we've got Laura's also adding condensation. Excuse me, I've skipped slides. So yes, we do have evaporation of the squiggly lines that's coming up from when the sun heats the surface of the ground or the water. And this is an experiment you can do on a hot day. If you go outside, either at home or at the school grounds, and you find a bit of dark sort of asphalt or concrete somewhere safe, put a cup or so of water, and then around that mark, draw a line with chalk, and then come back and time it after a minute and see how that evaporation is actually reducing that size of the water. Sometimes when it's a lot of evaporation, you can actually see it turning to steam. So sometimes we get it when it's been a really afternoon thunderstorm, and then the sun comes back out and there's lots of water on the ground. You can often see steam rising back off the ground, and that is evaporation in process. Then we have it moves into the clouds. And then again, once the clouds get heavy, we get precipitation. We get that rain falling back down. And of course, then we get runoff, because things are going from the highest part to the lowest part, and it will run off into the lowest parts, our creeks, our rivers, our lakes, and eventually some of it will soak into the ground, and then it will run off underground, and some will run off as surface. We see this a lot after lots and lots of rain. We get something called our soils get full. It's called super saturated, and it means that there's no more room. So imagine a sponge. If you squeeze all the water out of the sponge, again, another experiment you can do at home or at school, squeeze all the water out of a sponge and then gently pour in more water. Once that sponge is full, it won't absorb any more water and the water will run straight out. So you can demonstrate this exactly what happens in our soils after lots of floods or lots of heavy rains, that it can't absorb or take in any more water. The soil, all the little gaps in it, like a sponge, and the water will then run off the surface. And that's when we can get things like flash floods and flooding after very heavy rain, when that soil can't take any more moisture. Excellent. Now, within the water cycle, when it's falling on our land masses, we have areas called catchments. And you may have heard of a catchment before. We often use it when we talk about schools, what school to go to, you're in the school catchment. But this is something that's about the actual way the land is sloped. So if we look at the first map of Australia here, we can see these different catchments. Now, the Murray-Darling Basin is the largest catchment in Australia, and it actually really is about 1/7 of the Australian landmass. And we can see that we've got the southeast coast catchment on the other side. That's because we've got a mountain range that's in between those two catchments. So water will flow on two different sides. Now, a catchment can be really big and small. You might, if you're in the Murray-Darling catchment, you might be able to have a look at this map and see which of those catchments you actually fall in. I'm actually in the Central Coast at the moment, so I'm falling in that southeast catchment, and I live near Brisbane Waters in near Woy Woy, and so we have lots of hills, and the water flows quite directly, quite quickly into the surrounding lakes and waterways. So Charlie's asking, so if it floods a lot, will it eventually cause more floods? So if it continues to rain, once the ground is full, that sponge is full, then yes, you will get more and more floods. Once it stops raining and there's enough time for that water to be evaporated or to run off into those creeks and waterways, it does stop, it does go away, and the water will end up not being, soils will not be saturated anymore. So it's a period of time. But if there's a lot of rain, and it continues day after day, the soils get full, that sponge gets full, then you will get floods. It very much depends on the location. Some places are much more prone to flooding than others because of the shape of their catchment. If the town is at the bottom of a catchment and they've got lots of hills surrounding them, the water has nowhere to go. So it ends up there, and it's like almost filling up a bathtub, and it takes longer and longer for that water to drain away. Different areas will flood in very different ways. Places up here in the Lake Eyre catchment and further north, they get a lot of their rain from northern Australia. I was at a place called Birdsville, which I'm guessing is somewhere, it's southwestern Queensland. And I was there, it flooded twice in 1 year, but they didn't have any rain because all the water was actually flowing from the wet season up in the northern areas of Queensland, and it ran down. So it was very, very flat area, and it runs down what's called the Channel Country and ends up coming out down in South Australia. So it's a really interesting point that sometimes you can get no rain, but you can still have floods, depending on the shape of those catchments. So Charlie's in South Australia, is in the Gulf, and our major river is the Murray, mostly in Adelaide suburbs and going to Victoria. Yeah, absolutely. So yeah, that's where a lot of the water is ending up in those catchments. Now, I'm just going to show you, I have put my remote control is under my questions. I'm just going to stop sharing for a moment. We're going to have a look at a catchment I built. So this is something that you can also do at school. This, I've just used some clay, and I've just used a little container here. I won't tilt it too much because it'll affect my water. So what we're going to look at is what happens when the water hits this area. So first of all, this is not like rain. This is going to be more like big drops. So as I'm dropping it, you can have a guess. I'm trying to stay in the middle, which way it's going to flow. So the ridge is the end of my catchment. So this would be one catchment on one side, one catchment on the other. And as the rain falls, it will flow down in two different directions and eventually be caught in the bottom. So we can actually see it pooling in the creeks and lakes at the bottom there. So you can try this as well with a sand pit. You can also do it by putting lots of vegetation in as well, and to see if that affects the water. You can actually use and put sponges in as well to make lakes and other material. But if I try to simulate rain a little bit better, you can see that if the rain's falling, it spreads out. So you might get rain on the middle of the catchment, and it flows down both sides of the catchment there. So catchments can be really big and small. So even though the Murray-Darling Basin is a catchment, and I'll show that picture again, inside the Murray-Darling Basin, there are those smaller catchments within it, usually with rivers, creeks, or hills being the divider between the different catchments. But within those ones, they get smaller and smaller again. So you can look at Google Maps for where you live and where your school is or where your home is, and you can look at the different satellite images. Sometimes you can see the different slopes, and you can work out how big your local catchment is. The other way to do it is to follow the rain. Put a raincoat on and some gumboots and see which way the water's flowing from outside your house. So you will have stormwater drains, and so they will run into, some places they'll run down into those stormwater drains, but other times they will run over the ground into the creek. So you can actually look at that when it's raining as well to understand your catchment. Now, one of the other properties of water, which is really important, is something called surface tension. Sorry, I'll just move my catchment. So surface tension is the ability for water molecules to stick together. Now, you may have heard water being called H2O, and it's called H2O because the molecules, the atoms make up a molecule, and it's hydrogen, 2 hydrogens, and 1 oxygen. So H2O means hydrogen, 2, 1 oxygen. And those molecules like to stick together. And it creates something called surface tension. And surface tension is the reason why our little insects like this can walk on water. We can see that even though the legs are denting the water, they're not going through because of their weight, they're light, and they've spread their body out. Now, I'm hopefully going to demonstrate some water tension for you. We'll see how we go. Oh, there we go. So let me unshare again. And I've just, because there's a lot of water and I've got a lot of equipment here today, I want to be super careful that I don't spill anything on my microphone. So if I'm being very gentle, that is the reason why. Let's see if this is going to be close enough. Oh. Here we go. So I've got my water here, and I'm just going to try to fill it up as much as I can. So what I've just been able to create there is a bubble on top of my water. And what that's allowing me to do is actually have it sitting above the glass. And I'm going to try not to move my table too much because it might not stay there. So again, this is something that you can demonstrate at home. And you probably tried it already when you filled your water up a little bit too far and it just didn't quite spill over. Now, I've got a safety pin here and I should be able to float it on the surface. I tried it with a paper clip before and it wouldn't work, but for some reason my paper clips are working. So this is the surface tension of the water in action. So the surface tension is holding these above. Now, if I put it down like that, it's going to drop straight down. So the reason why a lot of the insects can look like they're walking on water is because they are light and they spread their weight around. But if I put detergent as the detergent's mixing with the water, the paper clips are dropping. Let's see if the last one goes. There we go. So that's because the detergent breaks the surface tension. And it's actually really kind of an important thing. So when we're actually doing things like the washing up and we're using detergents to clean, we actually want that surface tension to be broken. But when we're thinking about our marine environments, we don't want our animals to sink through. So that is one of the reasons why it is really important to avoid pollution in our waterways, because it can do something as simple as break the surface tension. Oh, Charlie's also mentioning that, yeah, insects can walk on water, absolutely, because it is that spreading their surface tension around. Okay, so what I'm going to do is try to move my glass that is very full now. I'm going to take some of the water out of it because I don't think I'm going to be able to move it without making a big mess. Let's have a look at our slides. And remember, please put your questions in the Q&A if you've got them going along. Oh, there we go. So a lot of these experiments you can try at school or at home as well. One of the tricks is make sure that you don't have any detergent in the glass from anything before, because yeah, if you've used the cup for anything else or it's got suds on it still from the washing up, it will end up not working very well. Excellent. So now I've got 2 cups of water. So what we're looking at here is the impact of oil. So we just had a look at the impact of detergents on our water. Oil has another big impact as well. So, and it comes from lots of sources. We get some from factories, we get some air pollution ends up settling in the water, runoff from land surfaces, fuel from planes, extracting petroleum, we get some leaks in the oil as well, and transporting it from accidental spills, but also there's from natural seepage of oils into the environment as well. And as I mentioned, 80% of the pollution does enter our the oceans from land. So the oils are a big one because they cause this. They cause what we call an oil slick, because oil and water don't mix. And I might just be able to demonstrate that one for you now as well. Oh, I've already put detergent in my container. So let me switch these around and we're going to try it on something else. So this is another experiment that you can do. I don't think I've got quite enough. We'll have a look at the oil when we do our next experiment, because we're going to use oil in that one. So it floats along the surface of the water. And what that means is we think about animals that feed in the water. So birds especially that might dive into the water to get their food, they get covered in oil, and the oil impacts their feathers and their ability to stay warm and dry. The same thing for marine mammals. it can have a big impact. I just had a question there from Ramina about whether boats are affected by surface tension. So the engineering of the boats work by spreading their weight out. But yes, absolutely, the properties of water is one of the things that enables that to work. So that's why boats that have very broad, wide bottoms can float really well. Again, a great experiment you can do with some aluminium and foil, making different shaped boats, floating them in water, either putting little rocks or coins in them to see how much weight you can have your boats weigh. So it's a really good fun competition that you can have different designed foil boats and how many heavy things they can carry. So marine animals, marine birds and mammals are very much affected by the oil, and eventually it will sink and it will end up in the water column. You've also got the issue with, say, fish that are under the water, or reptiles, marine reptiles and freshwater reptiles that need to come up to the surface to breathe. So if the fish are coming up to feed, and a lot of fish will feed on some of the insects, especially around rivers and lakes, the insects that are living around there, mosquito larvae, mayfly larvae, all those kinds of things that they're coming up to eat. And also the marine reptiles need to come up to breathe. So when they come up to the surface, they go through a coating of oil that impacts them as well. So Charlie's just asking, so when we float on water or in the pool, because you're spreading your arms and legs out like an insect, yeah, absolutely. If you do try that, and if you spread your body out nice and flat, it is far easier to float than if you've got your arms and your legs in a straight line together. Often I find that my legs will sink and just the top of my body will float. But that's another way to demonstrate. You could also try it with maybe a pool noodle and give yourself an extra set of legs like an insect, and you'll be able to see that you'll float even more. But absolutely, spreading out and making taking up as much sort of room as possible means you're spreading your weight around, and it's more easy to float. Okay, so this is an area that is actually near Parramatta River, for those of you that were asking about Parramatta River before. And this is an area that used to be concrete stormwater channels that they've made into a more natural environment. But because concrete channels, water moves really, really quickly. It's a very efficient, effective way to get water from one point to another. Concrete straight lines. But unfortunately, a lot of water can move very quickly. And this is what's happened. So uphill, there was concrete roads, concrete gutters, concrete stormwater channels, and that has washed into this semi-natural environment. And all of that leaf litter, we can actually see a tree has fallen down and has actually got stuck in the bridge. And then all of this material behind it has got stuck. But we can also see cans, bottles, so rubbish as well as plant material has got stuck in the bridge as well. Riley's asking about how the fish and the turtles will be impacted by the oil. So absolutely, because they're under the water when they're coming up to the surface. If they get that layer of oil on them, it can affect their gills, it can affect their breathing. Sometimes it will affect their what's called the buoyancy, about them being able to go up and down. So yeah, there certainly are impacts there as well. So what we can see here is lots of debris, not all pollution, but because it's ended up, it's now blocking that creek. Now, I know from this place here, they actually had to rip that bridge out, and they don't have it there anymore because it kept getting blocked. So it was obviously not in the right spot. So when things end up in the water, 80% of our waterways come from our litter comes from our waterways. Plastic bags, bottle, food wrappers. Microplastics are ending up being one of the most dangerous impacts of pollution. And a microplastic is plastic that is bumped into each other over time and it breaks down. So it breaks down into smaller and smaller pieces. When they've been doing exploration of the marine environments, and especially down in some of the deep sea trenches, they have found plastic. It ends up everywhere. Oh, here we go. So Charlie's just mentioning about the Roman aqueducts. So they did the same thing. That very, very small slope over a long distance enabled them to move large volumes of water to areas that may have needed it. So yes, using the flow of water has been happening for thousands of years. So this particular picture, again, is looking at essentially a natural thing. So this is sediment. Sediment is the soil and clay and sand that gets washed into the waterways. But this has happened after our big bushfire events. So big bushfire events in 2020. After that, we had a lot of rain. And what ended up happening is there was no vegetation protecting our soils. So what happened is all of the surface layer of those soils got washed into the water, and it created a big impact. So what this does, it stops the sunlight being able to get through and reach the marine plants and the marine animals. It can actually choke up different waterways. This can happen after floods around rivers and lakes, and it can actually change the course of the rivers. You'll often maybe look at old maps and see things like billabongs and lakes of a river or creek that does the curves, called a meandering creek. And when the water moves really, really fast, sometimes it can take those corners off. So we can change the way the water's flowing through our environments. And ultimately, this ends up going out to our oceans. Up in the Great Barrier Reef, this has been a really big problem because they're getting lots of erosion, and a lot of this sediment and soil is washing onto the reef, and it's settling on the reef. It's stopping all of the marine life getting sunlight, which they need to survive, and it is impacting the health of that environment. From Chris, when did pollution become such a big problem in the rivers? How long ago? Well, ever since there's been people, really. So certainly in Australia, the traditional First Nations peoples were very sustainable living on the land. So they would have been very, very careful about where water was being taken from, where people were making sure that nothing was running back into the river. Whereas if we think about the first arrivals in Australia, there was a stream in Sydney called the Tank Stream. Now, within a couple of years, the Tank Stream was so polluted, they couldn't use it to get water for the early colony because they dumped rubbish in it, they dumped sewage in it, and then they had to go further away to get fresh water, doing something like what Charlie was mentioning, like aqueducts. They were actually having a very simple version of that to bring water from another part of Sydney because they polluted the river so quickly. So when people are not living sustainably with the land, pollution happens far more quicker. Not thinking about when you put sewage in the water, if that's upstream from where you get your drinking water, people will get sick. And certainly in England, there was lots of diseases that came from people dumping sewage into the waterways. And a long time ago, people didn't realise that was ever going to be a problem, whereas people living more sustainably with the land always knew not to do those kinds of things. Charlie's saying here that pollution started because of the Industrial Revolution. Absolutely. And we started making things like plastics in the 50s, even before that, and it made our life easier. So after the Great Depression, when people were reusing things, like if you got a package and it had paper and string, you would reuse that material again and again. Whereas we got to this point after the Great Depression that things were around to make our life easier. So we started coming into a consumer driven, which means stuff. So instead of reusing things, we were disposing of things. So things had a one single life. Now we are going back into a time that we are looking at reusable items. Just think of recycling, reducing and reusing the amount of things. We find that is really getting far more common. Reducing single-use plastics. Lots of places have banned single-use straws, single-use plastic bags. We're using, even at the supermarket, you can buy plant-based plastic, compostable plastics that will break down far quicker in the environment, which is really important. So I'm going to demonstrate what can happen with our water. So I'm just going to have a think about how you can see this, and I won't make a mess. Oh, a little bit too close. This is a big jug. So what I've got here is a jug of clean water. And I want to have a look at what happens over time. So this is over time and space, thinking about that it's from the top of the catchment. So I want you just to imagine the different things that I'm putting in here. And again, you can do this at home and at school with the different materials that I've got. So first of all, we're going to think about a nice fresh piece of land that, 200 years ago, early colonial people decided that they wanted to farm this land. So one of the first things they do is clear the land. So we end up with lots of leaves and plants in our water, but also once that land is cleared and it rains, we'll get erosion like what we saw after the bushfires. So we end up getting lots of our really good clay and things that we actually want to keep on our soil to help us grow ends up in our water as well. So very quickly, our water, our runoff, is getting lots of other material in it. We don't have the plants to protect the soil and protect the edges of our coastline as well. Over time, unfortunately, people were not dealing with sewage properly, and it was flowing straight into the waterways. Up until relatively recently, we had ocean outfalls, and so we were just pumping the sewage out to sea, and we still have it now that around our coastlines, if there's been a lot of rain, we end up with sewage, and they put alerts out to say don't go swimming. So this toilet paper, and I promise you it is only yellow food colouring, is ending up in our water as well. So it's changing the colour. After we go through industrial times and mining, we might have things like this is some metals, detergents, and I'll give it a stir. We also, when we've got lots of farming as well, end up with using things like pesticides to keep our pests away from our animals, or we might use fertilizers to make things grow better, and they also will flow into our water as well. Now, I have to say on my end, this is smelling actually really, really nice because I've just used chocolate powder and detergent. So it's looking and smelling great, but in the real world, this would be starting to smell really bad. It would be smelling of sewage. It would be smelling of animal poo as well, thinking about farm animals. We've cleared all the land. Those animals are going down to the edge of the creek to drink. They're tracking down mud and their poo is going into the water, but also any of those fertilizers and chemicals used in the farming practices end up in the water as well. If we've got a lot of industry, even from roads and cars, we get lots of bits of oil ending up in our waterway as well. And we'll see whether our oil is going to just kind of bubble up. You can just see it floating on the side there. And if I give it a good stir, because it's mixed with our detergent, the oil ends up everywhere. Also, things like plastic will end up in our waterways. After bushfires, we've got charcoal that flow into our waterways as well. So is it looking like a nice, healthy water environment? It's certainly changed a lot. So how can we fix this? A couple of the questions that we had is about that. What would we do to solve this problem? Any ideas? To get our water. So once it's already polluted, there are some ways that we can help make it better. But also, how can we stop these pollutions getting into our water in the first place? Now, some of the things have been solved. Most places in Australia will have sewage treatment plants, water treatment plants. So we really are looking after the water that comes into your home. But once it's in the stormwater and it's flowing in our rivers and creeks, it does often end up straight into our waterways and to our marine environments. Now, a physical barrier, if I actually put my paper towel in, that can act a little bit like a filter, I can actually, let's just go back to here a little bit, I can actually catch and get rid of most of those big pieces of material by using a direct kind of skimmer or filter. There are some fabulous technologies out there. One in the ocean is called sea bins. And what it does is collect a lot of those materials that are floating on the water. So what it'll do is it just lets it sort of sink through. So the water bottles and cans or plastic bags just kind of flow into the sea bin where it's collected. And then once it's full, that rubbish is removed. So there's some great technologies out there to help us remove some of this rubbish. Cleaning up plastic regularly on the banks, so no soil goes in. Yeah, absolutely. So really regular cleanup. So we just had Clean Up Australia Day on the weekend. It is a great one to get involved in, but you don't have to do it on one day. Even around the school grounds, look where your school grates are. Or if you're at home, look where your local stormwater grates are. Is there anything protecting it to stop rubbish getting in? So the grate itself protects big things, but certainly there are other ways that we can look at that as well. 3W, we can't litter, absolutely. Complain to the government to stop people doing it and make laws, absolutely, and grow more plants. Oh, they are all fabulous ideas there from 3W. So planting and what's often called sort of bush regeneration and creek stabilization, all of these things are about growing plants back on these areas, especially in areas that are flood zoned. So moving away from straight stormwater channels to having slower, what we call meandering rivers and creeks, slows the water down. And with plants on either side, if it does flood, it often can then get trapped. Having areas called wetlands are often areas that you can slow the water down as well. Charlie's also mentioning, using robot cleaners. In some parts of America, there are cleaners that do this, mostly due to YouTube donations. Yeah, there's actually some really good environmental companies that are doing some great things about cleaning up some of our waste to stop it getting into our marine environments. They've also recently discovered a plastic-eating bacteria that they're looking at being able to use to eat some of the plastic that's already out in the marine environments as well. We're almost out of time. I just want to show you a couple of slides of where places are trying to help. So having big stormwaters like that with nothing at the end can be a really big problem. So the idea of having a green filter, planting those plants, means that the water moves slower, can get to the environment where it's needed. What we call a grey funnel is when there's no trees. We've got stormwater channels, lots of gutters, hard surfaces, and that water and pollution gets washed straight into the waterways. The green filter can actually stop it. So you can plant rain gardens and natural spaces, replacing pavement with permeable pavers, which means the water soaks through, planting on rooftops, planting trees and vegetation will all slow that water down. Oh, I will show this one. So around mangroves and those wetlands, what happens is that sediment gets trapped. It is slowed down before it rushes off into the marine environment. So mangrove environments, grasses, any of those environments near the edge of waterways will slow the water down, dropping the sediment and in many cases the toxins as well, where it can be stored instead of flowing into the marine environment. And this is a great example of what can be done. So this is a stormwater drain, and instead of it just washing straight out, it's got a net on it. And as long as these nets are cleaned regularly, and you will see lots of councils doing this. So keep an eye out when you're traveling around in the car, on the bus, or on a train, or walking around your neighbourhood, the areas that do have these systems, because they catch vast amounts of rubbish, which is really, really important. Okay, well, thank you everyone for joining me today. I'm just going to go back through our original questions. So 5 Dock Early Learning Centre was, how clean is Parramatta River? Now, Parramatta River, the Parramatta River Catchment Group is a group of councils that work together to protect and to essentially make Parramatta River as clean as possible. It has a very long history of industry and chemicals and pollution. And lots of pollution meant that Parramatta River wasn't safe to swim in. And they are working really hard to make places that are clean enough for people to swim. But still now, they recommend that you do not eat fish that get caught in Parramatta River anywhere west of the Harbour Bridge. Now, the Harbour Bridge is quite close to the beginning of Sydney Harbour. So it's a really long way west of the Harbour Bridge, all the way up Parramatta River and all of the other sort of bays around that area, that they say not to eat the fish. And again, that is something that they are working on to try to improve. So the short answer is it's getting much better, but certainly it's still got a way to go. In terms of Melville High School, looking at your climate change impacts with the severity of weather is going to have issues on our rivers and our marine environments. In terms of runoff, in terms of the severity of floods, sea level rise causing more flood king tides. So if there's a big storm, when there's a really, really high tide, it can have a bigger impact further inland than it may do otherwise. So all of those increases are certainly a factor related to this in climate change. And in terms of how do humans impact this environment, we have a huge impact, but we also have a great opportunity to make a difference every day. So we can make a difference by what you were saying about not littering, cleaning up after yourself, reusing things, planting more trees. All of these are great ideas, and you can start making a difference in your very own backyard and your very own ground at school. Just understanding the catchment, understanding the flow of water in your environment is a great place to start. So we can contribute by keeping our waterways clean for the future, by creating those barriers, slowing our water down, planting those plants, putting nets or other catching devices to stop plastics entering our waterways. And yeah, we can filter some of that water out as well. Wonderful. Are there any final questions before we finish up? So certainly I've got to sort of, what do you do? So here I have just moved. So I've got an area where I've got water flowing through. So I've actually planted some plants. I'm looking at making sure that water is moving not too fast, but I also don't want it to sit there because we get a lot of mosquitoes. So it's having that real balance. So I use plants a lot. Recycling, we do return and earn to get rid of a lot of our cans and plastic bottles as well. As I said, recycle and reusing, upcycling and reusing things however you can is a great way to reduce the amount of rubbish that you have. So thank you all very much for joining me today. There are a lot, I'll send you some extra links about what you can do to help make a difference in these marine environments. But just remember, everything we do on land does have an impact in our waterways, both our freshwater ecosystems and our marine environment. So if we're being mindful and thinking about what we're doing, we can make a real difference, and we can start in our very own backyard. Thank you very much, and I look forward to seeing you all again soon.